Somewhere beneath the desert west of the Nile, machines are boring tunnels through solid sand, dozens of meters below the surface, carrying water to a place water was never supposed to reach. Above ground, satellite cameras are already picking up something that shouldn't exist. Perfect green circles blooming across what used to be nothing but rock and dust, hundreds of them, spreading further every year. Egypt is trying to build a second Nile, not a metaphor, an actual attempt to recreate artificially the single natural feature that built an entire civilization. And the reason this is happening isn't ambition for its own sake, it's survival math. So let's talk about why one of the oldest countries on Earth is now racing to reinvent its most defining resource, and whether it can actually pull it off. Because, make no mistake, this isn't a vanity project competing for headlines with Egypt's other famous megaprojects, the pyramids of glass and steel rising in the new administrative capital, the widened Suez Canal, the record-breaking museum sitting near the Giza Plateau. This one is quieter, buried mostly underground, and arguably matters more than any of them because it's not about prestige, it's about whether Egypt can keep feeding itself. To understand why this project exists at all, you have to understand just how completely Egypt depends on one river. Around 95% of the country's population lives within a narrow strip along the Nile or clustered where it fans out into the Mediterranean at the delta. Step outside that strip and you're in desert, immediately. Dramatically, there's barely any transition at all. Seen from space, Egypt looks almost absurd. A thin green thread running through an ocean of sand carrying tens of millions of lives on a ribbon of land you could practically walk across in an afternoon. For thousands of years, that arrangement worked because the Nile did something remarkable every single year it flooded, predictably reliably. It would rise, spread across the surrounding land, and then retreat, leaving behind a fresh layer of nutrient-rich silt that quietly renewed the soil's fertility without anyone lifting a finger. That annual cycle is, genuinely, one of the reasons a civilization capable of building the pyramids was able to feed itself well enough to do so in the first place. Then, in 1970, that cycle stopped. The completion of the Aswan High Dam gave Egypt something incredibly valuable: steady hydroelectric power and the ability to control irrigation year-round instead of being at the mercy of an unpredictable flood. It was, by most measures, a triumph of 20th century engineering, and it remains one of the defining infrastructure achievements of modern Egypt. But it came with a quiet, long-term cost. All that silt that used to spread naturally across the delta now settles behind the dam instead, trapped in Lake Nasser, piling up year after year on the reservoir floor rather than renewing farmland downstream. Farmers had to start leaning on artificial fertilizer to keep their land productive, and the entire foundation of Egyptian agriculture shifted from something the river did for free to something that now has to be manufactured and paid for, season after season, forever. That would be manageable on its own, but layer on top of it a population that has nearly doubled in the last 35 years, from around 60 million in 1990 to more than 100 million people today. Almost all of it still squeezed onto that same narrow strip of livable land running alongside the river. Cities have crept outward into farmland because there's nowhere else for people to go, which means Egypt is losing agricultural land at the exact moment it needs more of it, not less. Every new apartment block built on the edge of Cairo or Alexandria is, in a very real sense, a few more acres of farmland that no longer exist. The result is about as stark as it gets. Egypt, the country that once fed much of the ancient Mediterranean world, is today the single largest wheat importer on the entire planet. When Russia's invasion of Ukraine disrupted global grain shipments in 2022, Egypt felt it immediately and painfully, because so much of its food supply now depends on ships arriving from somewhere else entirely, at prices Egypt doesn't control. And then there's the piece of this story that isn't even happening inside Egypt's borders. Upstream, in Ethiopia, sits the Grand Ethiopian Renaissance Dam, the largest hydroelectric project anywhere on the African continent, and a genuine point of national pride for Ethiopia, a symbol of the country's own development ambitions. For Egypt, though, it represents something closer to an existential question mark. Even a modest reduction in the water flowing downstream from that dam could ripple through Egyptian agriculture and water supply for decades, and Cairo has repeatedly warned that its water security is directly on the line. It's a tense, unresolved regional standoff between two nations who both, understandably, see the same river as central to their future. Ethiopia views the dam as its ticket to electrifying tens of millions of its own citizens, while Egypt views any reduction in downstream flow as a direct threat to a country that draws roughly 97% of its fresh water from the Nile and simply has nowhere else to turn for more. So Egypt is boxed in on almost every side. Its population is climbing, its farmland is shrinking. Its river's downstream flow now depends partly on a dam built by another country entirely. Something had to give, and back in 2018, Egypt's government announced its answer. the New Delta Project, an attempt to reclaim around 9,200 square kilometers of desert and turn it into productive farmland. Enough, if it fully succeeds, to expand Egypt's entire cultivated land base by more than a third. It's an area roughly the size of a small country, carved directly out of what has been empty desert for as long as anyone can remember. The project was formally inaugurated by President Abdel Fattah al-Sisi in May of 2026, along a corridor now known as the Sheikh Zayed Axis, stretching around 120 kilometers into the western desert. Total investment sits somewhere around $15 billion, overseen by a dedicated state body called the Future of Egypt Authority, and the whole thing has been elevated to the level of a national security priority, treated with the same seriousness Egypt gives to protecting the Suez Canal or the Aswan Dam itself. Now here's where the engineering gets genuinely fascinating, because you can't just decide to grow crops in the desert. You have to physically get water there first, and Egypt doesn't have spare Nile water sitting around waiting to be redirected. So the centerpiece of the entire project isn't really a farm at all. It's plumbing on an almost unimaginable scale. The largest single component is a channel called the Al Hammam Canal, stretching roughly 170 kilometers through the desert. What makes it clever, rather than just enormous, is what it's actually carrying. Instead of siphoning precious water directly out of the Nile, the canal is designed to capture agricultural drainage water, essentially the runoff and wastewater from existing farmland that would otherwise simply flow out into the Mediterranean and be lost for good. That water gets collected, redirected inland, and pushed toward the new desert farmland instead of being wasted at sea. A second, smaller system draws additional water directly from the Nile to supplement areas the recycled water can't fully cover. But moving all of that water isn't as simple as digging a trench and letting gravity do the work, because the geography fights you at every turn. Much of this system starts down near sea level, close to where drainage water collects at the edge of the existing delta, while the desert plateau it needs to reach sites around 100 meters higher, further. Inland. So engineers have installed a chain of pumping stations along the route, physically lifting the water in stages as it climbs inland, stage by stage, station by station, each one pushing the flow a little further and a little higher than the last. It's a genuinely unusual way to build a river. Rather than letting water find its own path downhill the way nature does, Egypt is essentially forcing it uphill against gravity, mile after mile, purely through the brute force of pumps and electricity. And in a desert climate where the sun can evaporate exposed water shockingly fast, sometimes losing a noticeable percentage of a canal's volume before it even reaches its destination. Large sections of the network actually run through big underground pipes instead of open channels, specifically to keep the water shielded from direct sunlight and cut down on evaporation losses along the way. Before any of that water reaches a single crop, though, it has to be cleaned. That job falls to the New Delta Water Treatment Plant. At a facility capable of processing millions of cubic meters of water every single day. And by some measures, it's the largest water treatment installation of its kind anywhere on the planet. Bigger than facilities serving major cities, despite existing purely to irrigate farmland that, until recently, didn't exist. Its entire purpose is to take lower quality drainage water, water that used to be considered essentially waste, discharged into the sea and forgotten, and turn it into something reliable enough to sustain large-scale farming, easing pressure on the Nile itself in the process. Standing at the center of a project this vast, that treatment plant might be the single most important piece of infrastructure nobody outside Egypt has ever heard of. Because without it functioning at full capacity, every canal, tunnel, and pumping station built to carry water toward the desert has nothing usable to deliver. And the results, at least from orbit, are already visible. Satellite imagery over the past couple of years shows large stretches of what used to be flat, featureless desert, now covered in the distinctive circular fields created by center pivot irrigation, those perfect green rings. You sometimes see scattered across satellite photos of farmland anywhere in the world. By 2024, thousands of square kilometers had reportedly already come under cultivation. For a government eager to point at tangible proof that this enormous investment is actually working, those images are exactly the kind of evidence they want to show the world. But here's where the story gets more complicated, and where it's worth pausing before declaring victory. Analysts studying the region have found that a significant portion of the water currently irrigating these new fields isn't actually coming from the Al Hammam Canal system at all. It's coming from underground aquifers instead. Ancient reserves of groundwater that built up over thousands of years and that refill, if at all, at a pace measured in centuries, not seasons. Some of this water is part of what's known as fossil water, trapped underground since long before the modern Egyptian state existed, and once it's pumped out, there's no meaningful way to put it back. Research using satellite data has suggested that groundwater depletion in parts of the western desert has been accelerating, which raises an uncomfortable question sitting right at the heart of this entire project. If a meaningful share of this new Nile is quietly running on a non-renewable water source, what happens to all that farmland once that groundwater runs dry? Egypt would essentially have converted an unreplenishable ancient resource into a few decades of crop yields, only to be left facing the same land and water shortage it started with, just further out in the desert, with the underlying aquifer permanently drawn down and no obvious way to recharge it on any time scale that matters to the people farming above it. There's also a fair question about who actually benefits from all this new farmland once it's productive. Much of what's being grown in the reclaimed areas leans toward higher value export crops. Fruit, vegetables, nuts, destined for supermarket shelves in Europe and the Gulf, rather than the staple grains Egypt is desperately short on at home. The government's argument is straightforward. Exporting those crops earns the foreign currency needed to keep buying wheat on the global market, so it still strengthens food security indirectly, even if the desert itself isn't growing bread wheat. Critics see it differently, arguing that growing premium produce for overseas buyers does little to close the actual gap between what Egypt eats and what Egypt grows, and that the country's underlying dependence on imported staples remains basically unchanged no matter how green the desert gets. There's also a quieter concern about who gets to farm this new land in the first place. Large-scale reclamation projects in Egypt have historically tended to favor big agribusiness operations with the capital to invest in center-pivot irrigation systems and export logistics, rather than smallholder farmers, raising questions about whether the economic benefits of the new delta will actually trickle down to ordinary Egyptians or concentrate among a smaller set of well-connected operators. Egypt isn't the only country wrestling with this exact dilemma either, even if its version happens to be one of the most dramatic on Earth. Saudi Arabia spent decades pumping its own fossil aquifers to grow wheat in the middle of the Arabian desert, an experiment that briefly made the kingdom self-sufficient in grain, before officials realized the water table was collapsing and largely abandoned the strategy. Israel, facing chronic water scarcity of its own, went the opposite direction, investing heavily in desalination and wastewater recycling rather than mining groundwater, and now recycles a larger share of its wastewater for agriculture than almost anywhere else on the planet. California's Central Valley has spent the better part of a century locked in its own slow-motion groundwater crisis, watching the land itself physically sink in places as aquifers are drained faster than nature can refill them. Egypt's new Delta project borrows a bit from each of these playbooks, recycling drainage water like Israel, reclaiming desert like Saudi Arabia once tried, and worryingly, leaning on ancient groundwater the way California has learned to regret. Whether Egypt manages to take the lessons from those other stories rather than repeat their mistakes may end up being the real measure of whether this project succeeds. None of this is happening in a historical vacuum either, and Egypt's own track record here is worth being honest about. Back in the late 1990s, the country attempted something strikingly similar with the Toshka project, an earlier effort to divert Nile water into the western desert and create an entirely new agricultural region from scratch, complete with its own promised new cities and a target of eventually resettling millions of people away from the crowded Nile Valley. Despite serious money and serious ambition behind it, Toshka fell dramatically short of its original targets. Technical setbacks, funding gaps, and the same underlying water availability problems that shadow the new Delta project today all conspired to leave it a fraction of what was originally envisioned. And today it's often cited as a cautionary tale rather than a template for success. Egypt has also built a string of brand new desert cities over the past decade, including its sprawling new capital east of Cairo, intended to relieve pressure on an overcrowded Nile Valley and give the government a modern administrative base outside the congestion of old Cairo. And while some of those developments are progressing, others have struggled to actually attract the populations they were designed to house, leaving vast, gleaming residential districts sitting largely empty years after completion. Ambition in modern Egyptian infrastructure has not always translated cleanly into results. So the new Delta project is really being watched through two very different lenses at once. On one hand, there's undeniable, visible, satellite-confirmed progress. Canals dug, a record-scale treatment plant running, thousands of square kilometers already converted from barren desert into working farmland in a matter of a few years, which, by any measure, is a genuine engineering achievement. On the other hand, there are real structural question marks hanging over the whole enterprise. How much of this is quietly borrowing against a groundwater supply that can't be paid back? Whether the crops being grown actually solve the food security problem the project was built to address, and whether Egypt's history with megaprojects like this suggests caution rather than confidence. What makes this particular story worth watching closely isn't really the size of the canal or the price tag on the treatment plant, impressive as both are. It's the fact that Egypt is essentially trying to answer a question that a lot of dry, water-stressed countries around the world are quietly asking themselves too. Can you engineer your way around a resource constraint that nature never intended you to have? Can recycled water, underground pumping stations, and sheer construction ambition actually substitute for a river that took millions of years to shape a civilization around? Egypt has spent roughly 5,000 years learning how to live with the Nile, reading its floods, managing its silt, building its cities along its banks. The new Delta Project is, in a very real sense, an attempt to take everything that knowledge produced and apply it to a landscape the Nile never touched in the first place. Whether that turns out to be one of the great engineering triumphs of this century, or simply the newest chapter in a long history of desert megaprojects that promised more than they delivered, is still genuinely unresolved. What makes it different from Toshka, at least on paper, is scale and sequencing. This time, the water infrastructure came first, with treatment plants and canals built before farmers were sent out to plant, rather than the other way around. That alone might be enough to avoid Toshka's fate, but scale cuts both ways too. A project attempting to reclaim an area the size of a small country carries risks that are proportionally larger as well, and a mistake made at this size. An aquifer drained faster than expected, a treatment plant that can't keep pace with demand, a canal system that costs more to run than the crops it grows are worth, would be far harder and far more expensive to walk back than anything Egypt has attempted before. The tunnels are being dug either way. The fields are already turning green. What happens to them in 20 years, once the easy groundwater is gone and the true cost of the water bill comes due, is the part of this story nobody can answer yet. If you want to see how Egypt's second Nile actually turns out, stick around, because we'll be following this one as it unfolds.